So in this video, I'm going to introduce you to the idea of acceleration. And really, this should be an intuitive concept to you. I'm sure that when you hear the word acceleration, the idea of speeding up comes to mind. If you accelerate a vehicle, it means you're going faster. But in physics, it means a little bit more than that. The actual definition of acceleration is change in velocity over time. And like the velocity equation or definition, the equation is in the definition. So we see change in velocity. So change, remember, is written in math with the Greek letter delta, and we use v for velocity over time, so divided by time, gives us acceleration. Now, with this equation, we are also able to figure out or derive the unit. So the base unit for velocity was displacement over time, so meters over seconds. And then for acceleration, we then also have that over another time unit, so that would be seconds. So you're typically seeing it written as meters per second. So it's the change in velocity for every unit time measurement. But you also might see it like this, meters per second squared. And what that does is it comes from, if you're divided by seconds here, that's the same as multiplying by 1 over seconds. And so you get the seconds squared on the bottom. So you may also see the unit expressed as this, meters per second squared. Now there's several different ways in which we can accelerate. The intuitive one I already talked about is speeding up, right? If you were to hit the gas pedal, you are going to go faster. However, just by looking at the definition here, we see that it has a broader application than that. So you can also slow down, and as you slow down, your velocity is changing. So in physics, acceleration can also mean slow down. And in another layman's term that people use for slowing down, obviously, is deceleration. And we don't typically use this in physics. We use the idea of positive or negative acceleration, but we'll see how that has different meanings based on what the direction of your velocity is here in a second. Now there's a third way in which you can change the velocity change the velocity as well. And it's important for this one to remember that velocity is a vector, which makes acceleration a vector as well, meaning that it has a direction. So you can change your velocity simply by changing your direction. And so turning is another example of accelerating. And this can be done even if you're not speeding up or slowing down. So if you take a turn at like 10 meters per second, by the sheer fact that you're turning, even though you're not going faster or going slower, you are considered to be accelerating because your direction is changing, and your direction is determines your velocity. Now, I do also want to look at the idea of positive and negative acceleration. So in order to do that, I'm going to quickly set up a coordinate system. So let's say this is 0 meters and this is 10 meters. And we're going to first start with a motion diagram where we have a vehicle that's going to start over here at 0 meters, and it's going to speed up to the right. So it starts slow, so my dots are very close together, and then they get further and further apart. And we can see that in the first little bit, I have some positive velocity that's very small, and then I have a positive velocity that gets a lot bigger, and then even bigger. And if I want to represent the change in that velocity, I can look at the difference in the size in vectors. So if I move this vector down here, right, the change would be this, and I'll do it in a different color. Right? So I have increased the velocity, and so you can see that vector points to the right. Well, that's your acceleration vector, and it's positive. So I have a positive acceleration, and in this case it means speeding up. Now let's say we draw a motion diagram for slowing down. So a car comes in from the left and it's already going fast, and as soon as it hits that 0 mark, it starts to slow down and my dots get closer together. So you can see initially it has a very large velocity, and then that velocity gets smaller and smaller and smaller, but it's still in the positive direction because it's still going towards the positive over here. So in this case, I have taken a velocity that is very large and I have made it smaller. So if I were to bring this one over here to just kind of demonstrate, I'm going to draw it really long like this. In order to achieve this shorter velocity vector, I must have pushed back against it, right? And so you would have the acceleration in this direction. It would be negative in order to get our velocity to be smaller. So in this case, positive acceleration meant speeding up, and negative acceleration meant slowing down. And that's pretty intuitive. However, there are instances where vehicles go backwards, right? So let's say a car is starting over here at the positive direction. So my car is going to start here, and it's going to go to the left, and it's going to start slow, right? And then it starts to get faster. Well, this is a velocity that is a negative velocity because you're moving backwards, and then a negative velocity that gets even bigger and then gets even larger in the negative direction. In this case, you're speeding up. However, you're speeding up in the negative direction. So in order to get more negative, if I were to move this one down here, I would have to have a negative acceleration. But in this instance, because I'm going backwards, this negative acceleration is no longer slowing down, but it's speeding up. Okay? Likewise, if I start out really fast, and then I slow down in the negative direction, I have a large negative velocity, and then I've got a smaller negative velocity, and then smaller, and then smaller. So in order for this vehicle to slow down, there would have to be some positive acceleration causing the negative velocity vector to get smaller, right? So the idea of having a positive acceleration or negative acceleration isn't directly tied to speeding up or slowing down. It depends on the velocity and the direction of your velocity. So just something to keep in mind. Now, one last thing I'm going to show you before this video ends is manipulating the velocity equation or the acceleration equation a little bit. So we said it was change in velocity over time is equal to acceleration. Well, remember that when we say the change in something, it means the final value minus the initial value. So I could rewrite this as the final velocity minus the initial velocity, and I write the initial velocity with that little 0. Sometimes you'll see it written with a little I. This. Over time is equal to acceleration. Now, quite often in the wording of problems, we can imply whether or not one of these terms is 0. So if a vehicle or something is starting from a stop, or if we drop something, then at the beginning of the problem, the initial velocity would be 0 meters per second, even though it might not say that blatantly in the problem. Another value we could imply is if the vehicle comes to rest or comes to a stop, then at the end that means that the final velocity is 0 meters per second. So this would be initial velocity 0 meters per second. This would be final velocity 0 meters per second. So sometimes that term cancels out. Now I'm going to manipulate this equation a little bit to show you how you typically see it on your reference tables. And it's just really this equation is just solved for final velocity. So typically how you'll see it is we multiply by t on both sides, and then we add final velocity. And so how it appears on a reference table is that your v final is equal to at plus v initial. But again, this is really just derived from this equation, and the idea that acceleration is the change in velocity over time.